Well, yeah, it's going from there. Okay, let's get started. Yes. So, hey, hi everyone. We have a tight group. Thanks all so much for coming. This is going to be casual and it's cool. I'm actually not here to sell you anything. We went through this process of building a GraphQL API over the last few months. We learned a lot of lessons, and if anyone here is maybe in the future building a GraphQL API, then what I hope you get out of this is some things that is going to allow you to maybe fast forward to maybe a few things that we went through. If you're an expert in GraphQL, maybe you can contribute to the conversation, or anyone obviously is welcome to contribute to the conversation. And if you're not into GraphQL at all, then maybe you just learn a little bit more about GraphQL. So I'm going to talk about the use case, why we need to build an API. I'm going to talk about the GraphQL design and developer experience considerations that emerged from that. And I'm just going to wrap it up with a little bit of where we're at, how we're moving forward, and stuff like that. All right? So this is my use case. By the way, I come from layer 7, and 20 years ago, we created this API gateway, which again, I'm not here to sell you today. But yeah, we didn't realize at the time, but 20 years later, we have the situation where people build a lot of value on top of this, and this is valuable to us. And the way that this, if you think about how people create value with our product is by, it's all about configuration, not code, right? That's kind of been the layer 7 thing from the beginning, right? So you define services and policies and connectors and data sources, and you subscribe to topics, or you've got patterns that you're arranging together, and you build these things together, and it creates this thing that is really meaningful for the customer, becomes, 20 years later, to a certain degree, part of some legacy infrastructure. But that configuration is the key to the value that the customer get from our solution. And so it's really important for us, right, to nurture this configuration and to allow the customer to govern it. So configuration management capabilities that are targeted by the API we're about to talk about are bundling configuration, applying configuration, copying, mapping, some configuration arithmetics, analyzing dependencies, right? We're talking about each customer has a unique combinations of thousands of interrelated entities, right? So it's really, really complex from a dependency perspective. We want to enable customers to do configuration as code. We want to allow customers to break their monoliths through that. And we want to power the future ops capabilities that we are releasing as part of our product with a solid foundation. And what happened, I'm just going to wrap up the use case here, is that we have this legacy API called RESTman, which is a REST-based API. It's XML-based. There wasn't, the perspective that we have 20 years later now, how important a component this is. Therefore, there maybe is not enough design thought put into it. It's really important for us, right? And so that has been identified as something that's keeping us from delivering the maximum or optimal configuration management capabilities that we want. So the new API has to be able to enable the bundling and managing of configuration as code. It has to allow for flexible grouping of different entity types, because different customers use and create configurations in different ways, right? Sometimes they break it down per API they're exposing. Sometimes they break it down per teams, so there's a lot of granularity that's different from customer to customer. We need to be able to analyze dependencies, but also the deltas between different gateways. So, customers go through revision history, and so basically you've got last week's configuration versus the one that you're about to deploy to staging. And so you need to figure out what is the delta between that. So in general, just easier governance of assets developed with layer 7, and also allow customers to break those monoliths, right? You've got this massive configuration, but the trend now, when people modernize their infrastructure, is instead of having these big monolith API gateways, is to have smaller API gateways that have fewer services listening on those gateways, because it makes it easier for you to scale a particular service or another, or things like that, right? From a DevOps perspective, that's just the trend, the current trend. So how did we land on GraphQL? We did an initial spike. We had this old API. We knew we could do way better than that. So we just did an initial spike, simple REST JSON API. We looked at GraphQL, because we realized that we could get a lot for free. And some of the requirements we were getting were things like, hey, I want to be able to get those policies, let's say, defined on the gateway, but I don't want all of the policy. I just want maybe the names and a checksum of it, because I want to be able to do those deltas and stuff like that, right? These XML documents that you get from the legacy API, sometimes you get like a single XML document that's like 90 megabytes, really, really hard data to work with. We did a limited implementation for some initial capabilities, and it really performed well. One of the issues with our legacy API is the performance. Sometimes customer will try to pull the configuration, and it will take almost an hour for it to come back. Sometimes there's timeouts involved. It is definitely problematic. And the data is so complex that it really needs to perform. And GraphQL in that initial spike realized that, holy cow, this is really fast. So we stopped implementing that spike, and we just looked at design for a while. We spent months and months figuring out how this thing should look. The GraphQL schema aspect of it was definitely the most time-consuming from the perspective of building this API. And then we just started implementing with this new, more sophisticated, I shouldn't say complex, more sophisticated schema, and we're still moving that direction right now. Can you see okay there? Yeah, feel free to move if you want. So yeah, I don't have a slide on what is GraphQL, because I'm hoping people are past that, but just in general, in case you're not, right, GraphQL has GraphQL Queries and GraphQL Mutations, right, which is different from REST, where you have different verbs, right? So a GraphQL query is kind of like a REST a query where you do an HTTP GET, typically, right? Whereas GraphQL Mutations would be the equivalent of an HTTP post and HTTP put. So mutations are writing the data, and query is about getting the data, right? So the query, the syntax that we adopted so far is on the left here. So we have no verbs in the queries, right? Trusted certs by DN, trusted certs by thumbprint. There's no verb. We use the by in this case. We have a simple input type. So in the case of trusted cert by DN, the input type is just a string. But we were really tempted, and we're still considering adopting a more sophisticated query syntax that looks like this. So notice how here there's only one query. It's called trusted certs. But the input itself is not a simple type, right? In this case, I have a query input in which I can put filters, and maybe I want to be able to sort the data coming back. Maybe I need pagination, stuff like that. We don't actually need those things right now. But the reason we're considering doing that, and that's like a really key thing about GraphQL, is to allow for the API to evolve without breaking the previous clients that have been implemented on this. So by creating a wrapper input type into a query like this, allows you to evolve over time, right? We don't need sort and pagination right now, but yeah, maybe it would be nice to have filters instead of having 3 different queries by this, by this, by that. There's a filter, and then I can put these input parameters, right? So the ability to adding this wrapper input type is something that we think is going to help us over time when we evolve the API. One of the things about GraphQL that we ran into a couple of times that is a challenge that we needed to overcome was the concept of these recursive type, right? Consider like a folder system, right? So in our layer 7 gateway, you organize policies and service in a folder structure, and the customer decides what those are, right? But a folder has subfolders, so you could technically have infinite nesting. And that, when you want to query data and say, you know, give me all the subdirectories of a particular object, GraphQL doesn't lend itself to that, because you have to be explicit about what you're querying and all the properties inside of your query. So the depth cannot be infinite, and you will run into this. If you read a little bit about GraphQL, that is one of the things that people run into very often. So the depth cannot be infinite. It needs to be explicit in the query. That is you know, something that we ran into. So here's the first way that we address this. The first mitigation, not necessarily mitigation, but it caused us to rethink about our object model, right? We have an API that's in front of in this case, a Java object model, but we can take the liberty of interpreting this object model. So for, you know, in our object model, there's an object called folder, right? But what really realize is that, well, what's in folders? What's in folders are services and policies. So we just have a property called folder path in these types, and we just say, you know what, folders don't exist. So our API now, if you are doing a mutation where you're setting services and policies and you specify a folder path, we're just going to create the folder object on behalf of the caller, and just, you know, we basically reimagined the object model in a way that the folder object doesn't exist anymore. When you do mutations, maybe you end up in situations where you end up with empty folders. So if there's no folder entity type, you can't delete it. So we automatically delete things that are left empty, right? Recursive type pattern mitigation number 2. So it's very important for us to do dependency analysis when we are looking, for example, in our case, policies that are applied to services. And because with layer 7, you can define a policy, and then you can have an include statement that includes that policy. You basically organize your repeated logic for your APIs in these policies, and then you just inherit them along to, you know, the top level policies that are associated with services. So that means that we have another recursive situation, because a policy can include a policy, can include a policy, can include a policy, and we want to be able to distinguish between, you know, just getting the top level dependencies versus going all the way down the dependency stack. And so the way that we address that in this case is by introducing 2 different properties, direct dependencies and all dependencies. And in all dependencies, you basically get back, you know, arrays of the different dependencies, and they're flat. And the fact that they don't, you know, embed each other doesn't matter, because in this case, I want to get all of the dependencies. And technically, I could go, you know, direct dependency, policy fragment, and get the dependency of that. And I could do, like, if I want to get only 2 level down, you could still do that if you want to. But now you also have a way to go all the way infinite depth by implementing that on the server side of the API. Okay, so we're still talking about queries and GraphQL types of challenges that you get into when you're designing an API. Here's something that pretty quickly we ran into, right? Just the case of, like, give me everything for your API. Just query everything. In REST/everything, you're done, right? Let me just show you, like, my query everything right now in Postman and show. Why isn't this working here? So, you know, one of the things that really made us doubt our approach was this. So look to bundle migrations. Let's look at my graph bundle all. Here's my query. This is just to say I want to get everything, right? So 60 lines, and it's growing. So we're at 60 lines now, but it's still growing. So how is this a problem or not? And what are some of the mitigations? The mitigations is like that Postman collection that I was showing you. You don't need to adjust the query. you just say send, right? The query is called everything. There's documentation about it. So if you don't need to change anything, the same way that you would do with a REST API, you can have the same developer experience by providing things like Postman collections. We have command line interface wrappers to like curl, for example, where you have sample queries that you can apply, and those queries themselves are hard-coded. We've also considered adding REST shortcuts to our GraphQL API so that you could go GraphQL/everything, and then on the gateway side, we don't actually have to implement that in the GraphQL API itself because we have our own policies that are governing that, so we can just translate that into the everything query. But we're actually not moving forward with that at the moment because we find that the complexity that you're getting from that is shielded by those mitigations by providing a DX that doesn't focus on the GraphQL details themselves. And I'll get more into that later. And we also rationalize this over time. I think now I don't see it so much as complexity that we're imposing on a DX, but rather as verbosity. It is true that it is verbose, it is specific, but there are definite advantages that we're running into. The definite advantages that I'll get into later. So another complexity that we are running into, or that we ran into, was basically the query response formatting, right? So imagine I'm getting configuration out of a gateway. I use a GraphQL query to get the data, and then I want to apply it to another gateway, so I would do a GraphQL mutation on my target, right? So the output of the query is what should be your configuration as code, and that is also the input into applying the configuration to target. But the corresponding GraphQL flow doesn't actually work just like that. The JSON that you get back from the query can't itself be directly applied to the mutation. So that's something that you're like, that's kind of annoying, right? But here's one of the reasons this is happening, right? So we're doing some dependency analysis for a web service here. And so deep in there, we're finding dependencies that have their own policies and stuff like that. When we apply a bundle of configuration, we want to apply a flat bundle where all of the policy fragments are together in one area, regardless of who they depend on and stuff like that. So we need to massage this information. In a GraphQL response, you have this prefix data, as part of that, which also, you don't want that on the input necessarily. And there are ways that you can, in a query, control a little bit how the response goes, but not sufficiently that we don't need to do transformations. So how do we deal with that? Because it's all JSON, and on the client side, JavaScript is definitely your friend for that. It's been really easy to address that on the client side, right? So again, when you think about the developer experience, that's the kind of tooling you provide to developers so that you don't have to think about things like that, but you can go in and tweak it if you want to. So I'll show you a couple examples. How am I doing for time here, Bill? I'm about halfway? You're good. Okay, cool. Right, so if you look at, for example, when I bundle configuration, so I have this Postman collection that I would give a developer, right? So bundle and configuration, I want to get a service and its dependencies. I've got this create bundle query that is going to give me a response. And before I apply the bundle here, notice how the GraphQL variable is an environment variable called package by resolution. So basically, what this does, in addition to, I can probably just run it. Yeah. So yeah, I don't have this, maybe /demo. Yeah, so here's what my response looks like, right? Data, and there's the dependencies in there. But there's an environment variable that has been set called package by resolution, and that has its own format, right? So, and the way that we are doing this is by using a Postman test script. So you just plug in your JavaScript in there, and so it just runs after your request comes back. So Postman test scripts are very convenient for addressing this, and also this is what the DX looks like right now. You get this README and stuff like that, and there's a bunch of samples and utils, and there's a bunch of different JavaScript to do various operations with the JSON that you're getting or inputting into the GraphQL API. So that's working really well. And so there are additional pre-existing reasons for differences between the input and the output, right? So in the case of configuration, you want to apply some environmental mapping. You want to templatize a configuration. So it is, you could not, even if there was a way to format the response in the same format, you still would need to make changes, right? There's secret management that we need to deal with as well. And this just general massaging of data, maybe you want to combine different services or different versions together. Okay, so we talked a little about GraphQL queries. Let's talk about GraphQL mutations. So here's what we settled on right now. So you have to think about, in this case, we have verbs, right? So in the case of queries, you didn't need verbs because you're just always getting data, right? Whereas in mutations, you're applying different things. So then we have things like verbs. So create, update, set, and delete. So create policy fragment, update policy fragment, set policy fragments. Notice the plural here. And so set is kind of like a combination of create and update, where you're passing an array, and the API is trying to be smart about if things already exist. So I'm going to update and try to make sure we don't override any dependencies, conflict, and things like that. So that's how we distinguish between that. And it's also a mutation that allows you to apply multiple entities at the same time. And then delete policy fragment. Separation of input concerns. So for example, in the case of update, you want to update a policy fragment. We separate what is required to identify the policy fragment from what we're actually changing about it. And then that separation is something that we didn't actually have at the beginning. We had only this type, and inside that type, we would read something about it in order to identify the target of the entity. So for example, the name. But by separating that, you've got a cleaner syntax, and it also allows you to do crazy things like, I'm going to update a service by changing its name. So it's a completely different service now, right? Or you change its ID or something like that. So sometimes you have one, sometimes you have both, sometimes you have the other. So in the case of delete, you're only identify what you're acting upon, as opposed to update, where you need both. If you're creating, you don't need to identify, you just need to provide the input. So those are the three different patterns. And under consideration is, like if you think about advanced mutations, what we'd like to do, we'd like to have an optional input property that are unused during a mutation. So for example, we calculate checksums in GraphQL queries. That's one of the options that you have that allows you to do impact analysis before you apply the data. But the checksum is not a property that you write into the data model itself. But it's still nice to have the option to include that into the data so that later on, before you apply the data, you can do an impact analysis. So that's something that we read into. Mutation payloads. In GraphQL, the response of a mutation is called a mutation payload. And the best practice is that each mutation has its own custom payload type. Initially, we were just returning the entity itself. And then we realized that, hey, no, we need to protect ourselves from the evolution of the API. So we have right now very simple entity types that we have a lot of ideas about expanding, right? So yeah, if you do an update policy fragment, we'll get you back the policy fragment. If you create a policy fragment, we'll do the same thing. But here are some of the ideas that we already have in our mind to extend those. So we don't want to wait to do everything before we can share the API with our initial customers, but we know we're going to want to do this advanced stuff. So for example, a rollback property. So in addition to the policy fragment that you just set, what if I want to get specify another property that gives me like the reverse thing that I just applied? And that allows me to do a rollback. We didn't actually have that in our legacy API. We kind of try to do it, but you don't really have a way to do a rollback until you actually apply the data, because you need to roll back to the state right when you apply the data, right? So this is a case where the API can generate the rollback as the mutation is being created. For example, if you're setting a bunch of policy fragments, I can imagine that we'd like to be able to distinguish between which fragments were set versus which ones were updated, right? So we're going to extend that. Yeah, there's a whole bunch of other things about like delete, or people also in payloads will sometimes have the concept of error. So the GraphQL best practice is, it's kind of weird coming from a REST perspective, but errors actually come back as an HTTP 200 with error information in the payload itself, depending on which layer the error happens in. So this changing payloads allows you to specify errors. So let's talk about, we've talked about a number of issues and a number of things that we had to go through when we designed our GraphQL API. And my concern is always the resulting client-side developer experience. We are trying to help our customers here. So we're always second-guessing ourselves. Is GraphQL too complex for this? But I think that using samples, customers would adopt this in a way that with only minor tweaks, they would be able to use this without being barely aware of the GraphQL layer, right? When I'm using, something that looks like this. So, right, I get this README. There's a bunch of utilities, right? In this case, we've got bash scripts, we've got some Node.js utilities, and we've got documentation that explains you how to do it. Sure, there are samples, right? For example, in here, if I go sample bundles, here's, I could give this one, no, not this bundle, but maybe how to create a query. So how do I do my everything query, right? There's actually no input, so I don't need to change that. But maybe in this query here, I would change, which folder I'm targeting. I want to get everything in that folder, right? So this query part is not something that I need to change, but in the documentation, I know that if I want to get a specific folder, I would just put its name here, right? So that would be the extent of my exposure to GraphQL in that type of developer experience situation. So what is the actual API then? Is it the GraphQL API? Or is it the client-side tooling that you add on top of it, right? If you're using, people are using REST APIs right now. They're already using things like SDKs and generated code snippets. If you're using like a protobuf, you're using a .proto file, right? It is not unusual, Postman collections, obviously, right? These things are there to help the developer adopt your API. And hard-coded queries, mutations, HTTP post wrappers, straight JSON manipulation. This stuff is, I would argue, still lighter weight than providing your developers a .proto, in my opinion. I'm not partial, I guess, on that. But so why does that GraphQL layer exist then? You could argue, like, if users are never going to go to the GraphQL layer, why do you even bother? Because it is complicated stuff for us to build. But what it is for us is that it empowers advanced users, right? Right now, I'm giving you an example with my tooling of how you can bundle the configuration together and how you can apply it and how you can do things with it. But we have consultants that are helping our customers. We have like support people that are expert users of the current legacy API at the same level that our customers are not necessarily, right? We already have like this client-side tooling for our legacy REST API, and that's the layer that our customers are working with today. But we have a few advanced power users that will want to go in that layer, and that helps me sleep at night because I know that it's going to protect us from being able to do more advanced stuff with our customers. So if you want to tailor how you package configuration, if you want to specialize analysis, right? In a troubleshooting situation, there's a lot of analysis power you can get out of this. If you want to build, imagine a configuration governance solution, right? Let's say I want to build a distributed authorization governance solution. You know, you could do a killer GUI with something like a GraphQL API like that, right? I'm not saying we're necessarily doing that, but some partners do, right? There's a company called Apidays that built an entire product around this legacy RESTman API. They would love this. Then they're gonna wish they had that 10 years ago for sure. So in conclusion, am I early, Bill?
Yeah, you're running a little bit early, but
we can have either a break or some questions or. But yeah, I would say that right now GraphQL as a choice is already paying off. So, and the way that it's paying off is that we already notice instances where there's innovation happening on the client side, on the requester side of the API. So I know that I'm empowering future users of this API by doing GraphQL. So we ran into, for an example that I put in here, is this concept of GUID conflict. So we had these UUIDs and configuration, and sometimes, you know, a customer, instead of like taking the configuration and moving from like a development to a production, they're going to like create a little delta manually here and then move some stuff, and that creates conflicts in object IDs that are, you know, inherited in your policies and stuff like that, and then you have to like manually resolve those and stuff like that. So just by crafting GraphQL queries of our existing GraphQL implementation so far, we have a really, really easy way to just give you the list of those conflicts and to actually go back and apply those modifications in your bundles. So this is an instance of innovation that happens on the client side. This is not something I build on the API itself. This is something that the tooling can do because GraphQL is very flexible. So where we are so far, you know, I would say half of the work easily has been in designing the schema as opposed to retrofit GraphQL into our application. That part has been surprisingly easy. We're using GraphQL-Java because it's Java. It really easy plugs into our existing object model. We just create resolvers and wrapper into the existing Java objects that we're trying to front with this. From a performance perspective, depending on, you know, the use case that you're using, we've observed 10 times faster to 100 times faster than the legacy API that we're replacing. It's not complete in the sense that there's just so many different entity types that our object model exposes. And so we have partial coverage like that. And we're kind of like alpha stage right now, where we're targeting internal developers, and hopefully our customers are going to see the benefit of that in a few months.